Hi, my name is Vasu Agarwal, and this is my term project for 15112, Fall 14 at Carnegie Mellon University. I've created a gesture tracking system which allows Python users to implement touchless computing into their programs with relative ease. Let's take a look at the example program to see how this is used. So here you'll see three different images. On the top left, you'll see the original camera feed. On the bottom left, you'll see a thresholded version of this camera feed, which is used for the computer to find the contours. Finally, on the bottom right, you will see the contours being traced out by a series of green points. Now, this contour is determined basically by just the largest contour the computer can find. More sophisticated algorithms were tried, however, the noise found in most camera systems integrated in webcams makes it very, very difficult to do something substantial. Now, around the green hand, you will see a red outline. This red outline is the convex hull of the contour. The convex hull is used for finding the convexity defects, which you can see as the red circles. Finally, the large green circle is the computer's idea of where the center of the hand is. Now, there's a series of dots inside the hand, which you can see when I move my hand. It traces the dots around. Those represent the last few points of the hand's center. These points are used to trace out the gestures and to do the gesture determination. Also, there is the radius of the green circle. This radius determines the distance for the computer in some sort of relative sense. So when I move my hand back, you can see that the distance measure on the top right will change. It'll decrease. So now the API comes preloaded with a series of gestures. So if I move my hand around, say horizontally, it'll detect right to left. Diagonally is another one. Sometimes it's a bit finicky. The templates are very, very strong, so the templates are based off of parametric functions in this case, though you can generate the list of points necessary to compare against any way you'd like. So I can do other things, other really interesting things, like a circle. Anyway, you can add your own gestures as well through a file you would give the API. So when you're instantiating the object for the processor, you can pass it a file which contains a series of points for the that define a gesture for the computer to check against. So now, if the computer doesn't find the file, it'll default to its normal gestures, and then it'll write a gesture file to check against the next time it loads. In addition, if you don't want to specify the gestures beforehand and you want to have the user record their own, there is a record functionality built in. So for example, you can see that when I move my hand upwards, no gesture detected, right? I've removed the vertical template, but I can initiate the recording. So now if I do this, a vertical line, it generates a random string for the vertical line's template name, and then, as you can see on the top right now, so I'm going to clear that top right by doing another gesture. I did a diagonal one, let me do an infinity as well. Oh, didn't work. Anyway, so now if I can redo the vertical, you can see that it now tracks that new gesture that we just created, which wasn't there before. Now, to each of these gestures, the programmer can bind their own functions. So, for example, I've bound a custom action to a diagonal. So here, I'll do the diagonal action. You can see that I made a smiley face appear. Now, the programmer has access to the center of the hand as a position, so I can track the center of the hand like so. In addition, as I mentioned, you have access to the distance in a relative sense, so you can see when I move my hand back, I can make the smiley face larger and smaller. And then just a interesting functionality, you can do something like this very easily. Obviously, this is extensible. So for example, I've mapped additionally to the infinity gesture, I've mapped the creation of an image of my term project mentor, as you can see here, also doing the nice paint effect. But this can be extended however you'd like. So that's about it. The code can all be found on GitHub. Everything is open source. There's more information about the algorithm in the About Me, in the README. I hope you enjoy and have a nice day.